Welcome to the second video on quadratic functions. So we are going to start from example 3. Convert f of x equals negative x squared negative 2x plus 1 to standard form by completing the square. Okay, so let's see how we are going to do this. So f of x is negative x squared negative 2x plus 1, and you take out negative 1 out as a factor, then you get this. Now we are going to replace these two as we did in the general function. So these two terms are equal to this thing. So if you expand this, you get x squared plus 2 times 1 is 2x plus 1. You don't need plus 1 here, so you subtract it. Okay, then you get this, only these two, and you have negative 1. Okay, so you have to remember how to expand a plus b parentheses squared, okay, in order to do this. So so this negative 1 and this negative 1 will become negative 2, and you distribute the negative 1, and this becomes negative, this becomes positive, and this is the standard form. Okay, so the important step is this step, how you are going to replace this by this. So this is actually equal to this, so they are the same thing. If you expand this and simplify, you get these two terms. Okay, convert f of x equals negative x squared negative 2x plus 1 to standard form and draw its graph. What is its maximum minimum value? When is it attained? So f of x, you take out negative 1, and when you take out negative 1, this becomes x squared, this becomes plus 2x, this becomes negative 1. Okay, so you have to divide each term by negative 1 and you take out negative 1 as a factor. So when you send it back, you get the same thing. Okay, so this is actually negative 1 you are taking, like negative means negative 1. So again you have to replace these two terms. So when you simplify this, you get this. So you get this one, negative 1 is negative 2. Then you distribute, this becomes negative, this becomes positive. Okay, so you have to write it in the exact standard form so that you get you can identify h and k. So here is h is actually negative 1. Okay, and plus 2 is so k is 2. So you have to write it as a difference, x minus something. Then a is negative 1, h is negative 1, and k is 2. Okay, so you have to draw the graph. So since a is negative, it's a parabola that opens downward and has a maximum value. Vertex is negative 1, 2. To find x-intercepts, you have to solve the equation. So these are the solutions. X-intercepts, so these are the two x-intercepts. So this negative 1 plus root 2 is positive because root 2 is greater than 1. Okay, so square root of 1 would be 1, square root of anything greater than 1 would be greater than 1, because square root is an increasing function. So this is positive, this is negative. Okay, so that's important when you are going to sketch the graph. Okay, so this graph is opening downward and has a maximum value, and you know the vertex because we did the completing the square earlier. So now if you find the y-intercept, you can draw. So y-intercept is just 0, 1. You just calculate f of 0. So when you calculate f of 0, f of 0 would be just 1. Okay, now draw. So you get this when you draw. So y-intercept is 1, x-intercepts are these two, so this will be positive, okay, and the other one is negative, and the vertex negative 1, 2. So negative 1, 2. So this has a maximum and opens downward. Okay. So the maximum value is 2 and it is attained when x is negative 1. Okay. Okay. So we come to another example. So this is actually a practical example of a practical problem. So it will take some time to understand the problem. So you have 100 yards of fencing to build a rectangular enclosure for your puppy to roam outside of the home, with one side of the enclosure being the backside of the house. Find the dimensions of the enclosure so that the puppy has the maximum possible area to roam. What is the maximum possible area? So you have to find the dimensions of the enclosure so that the area here is maximum. Okay, so maximum possible area. So what we are going to do is we have to express the area of this rectangular enclosure in terms of x and y, and then convert it into a function of x or y only. So if that function is a quadratic function, we can find the maximum or the minimum. In this case it will be a maximum, and when that maximum occurs. So from that we can find the dimensions. Okay, so the first step is to express the area in terms of x and y. So area of this rectangular enclosure is x times y. Okay, and the other thing is so we are using the back side of our house as one side of the enclosure, so you only need to fence 3 sides of the enclosure. Okay, so you have 100 yards and it will only be used to used for these for these 3 sides. Okay, we won't use fencing in this side because it's enclosed by the house, so we only need fencing here, here and here, only 3 sides. We need to fence only 3 sides. So since one side of the enclosure is the back side of the house, we only have to use fencing on the remaining 3 sides. Okay, so so we will have 2 equations. One would be the length of the fencing, which is 100 yards. So since we are only using fencing on 3 sides, 100 yards will be equal to y plus x plus y, which is x plus 2y. Okay, so we only use it on 3 sides. So if it was 4 sides, then it would be 2x plus 2y. But since we don't have since we don't use fencing on this side, it's x plus 2y. Okay, so x plus 2y is equal to 100 yards. Okay, that's one equation, and the other equation would be for the area, which is area equals x times y. That means a equals xy. Okay, so this is the second equation. So we have to express a as a function of one variable only, because here you have two variables. So you substitute for x or y, then you get a function of y only or x only. So express a as a function of one variable, either x or y. It doesn't matter which variable you choose, you can choose anyone. Here we are expressing it as a function of y only, so I'm using so I'm going to express it as a function of y only, but you can substitute for y and get a function of x only as well. Okay, so so from this equation, if we solve for x, you will get x equals 100 minus 2y. So you can substitute 100 minus 2y for x for this x here. Okay, 100 minus 2y for this x, then parenthesis is very important, times y, this y. Okay, and when you distribute, you get this, which is a quadratic function, and here a is negative, which will give you a maximum value as expected. Okay. So also you can substitute for y. So if you solve for y, you get 100 minus x whole thing divided by 2. So you can substitute that here, then you get a function of x only. So again, if you distribute x inside, then and if you divide by 2, you again get a quadratic function, but it would be a quadratic function of x only, but the answer would be the same. Okay, now we are going to find the maximum value of this quadratic function. So we have expressed a as a function of y only. So identify a, b, and c, and a is negative, so function has a maximum as expected, and we attain the maximum at negative b over 2a, which we discussed earlier when we did completing the square. So if you substitute b and a, you get it as, so here you have negative, so negative and negative will make it positive, and you get 25 yards. So when y is 25 yards, you get the maximum area. Okay, so the maximum area is, when you substitute y equals 25 into this function, you get the maximum area. So you substitute 25 for each instance of y. So this is the maximum area, maximum possible area. And to find the dimensions, you also need to find x. So to find x, you solve this equation with the value for y substituted here. So the value for y is 25. So if you substitute 25 here, it will be 50. 2 times 25, 50. And if you take it to the other side, it will be minus 50, and you'll have x equals 50. Okay, so x is 50, so it's a 50 by 25 yards enclosure, which will give you the maximum possible area. Okay, so this is a simple practical problem that can be solved using the knowledge of quadratic functions. Okay, so this is actually a very simple example. There are many examples like this in physics and other fields of study. So also you can convert AY into standard form by completing the square and then identify the maximum and when it occurs. Okay, so that way also you can do if you forget this. Okay, so you can try that as an exercise, and you should get the same answer if you do it correctly. Okay, so that's our video presentations about quadratic functions. Thanks for watching.